We are on the verge of a massive leap forward in artificial intelligence. And the blueprint for it? Well, it might just be sitting right inside our own skulls. Today, we're going to dive into how the brain's ancient secrets are paving the way for a totally new generation of intelligent machines. Let's get into it. So it all starts with this strange paradox. On the one hand, you've got an AI that can crush a chess grandmaster, a complete supercomputer brain. But on the other hand, that very same AI can be totally stumped by a problem a simple little mouse solves every single day. So what's going on here? What's the real difference between these two kinds of intelligence?
Well, here it is. The AI is a champion of static, predictable worlds. Think of a chessboard. The rules are fixed. They never ever change. The mouse, though, it lives in our world, a messy, chaotic, and totally unpredictable place. It has to adapt on the fly to survive. And it's that one skill, adaptation, that has been the white whale for our most powerful AIs.
Which brings us to the billion-dollar question, right? How does a biological brain, this incredibly efficient little device that runs on less power than a dim light bulb, pull off this incredible feat of constant learning and adaptation? What is its secret sauce? All right, so the first major clue is kind of mind-bending. It turns out our brains aren't just reacting to the world around us. Nope, they are constantly predicting it. In a very real sense, your brain is always living a few milliseconds in the future. So how does it do that? It uses what neuroscientists call an internal model. And you should think of this less like a static map and more like a constantly running simulation of reality inside your head. Before you even reach for a cup of coffee, this model has already predicted its weight, its temperature, and the exact muscle movements you'll need. It's the brain's own personal crystal ball, and it keeps you one step ahead of, well, everything. But here's the thing, that model isn't fixed. It gets better and better through this super simple but incredibly powerful four-step loop. First, you observe the world. Then you make a prediction. And then, and this is where the magic happens, you feel the difference between your prediction and reality. That's called a prediction error. And that error isn't a failure. It's actually the most important signal for learning, telling your brain exactly how to tweak its model to be a little more accurate next time. This loop is running thousands of times a day, silently making you smarter. Okay, so that's the theory. But how powerful is this learning loop in the real world? Just how fast is it? To see that, we can look at some really amazing experiments with mice. In this study, a mouse had to figure out this really complicated maze. And if you look at its first attempts, the paths are, well, they're all over the place. Total chaos, right? Just trial and error. But watch what happens over time. Those paths become incredibly direct, super efficient. The mouse isn't just memorizing turns, it's actively building and refining a detailed mental map of its world. And get this. This is the part that is just astonishing. It only took about 20 trials for the mouse's performance to improve dramatically. This is something called few-shot learning. A traditional AI, it might need millions or even tens of millions of attempts to learn a task this complex. The brain just gets it. And you can see that incredible speed right here on this graph. Just look at how steep that learning curve is. The errors just plummet. That is the visual proof of the brain's learning engine firing on all cylinders. It is a masterclass in adapting at lightning speed. So the logical next step here is pretty obvious, isn't it? If we want to build an AI that can adapt like a living thing, well, maybe we should start building it more like a brain. And that's exactly the massive shift that's happening in AI research right now. One of the most fascinating examples is something called memory replay. You know how when you sleep, your brain replays events from the day to help lock in memories? Well, AI researchers are now building a digital version of that. They're teaching AIs to dream about their past experiences, letting them practice and reinforce what they've learned without needing new data all the time. And this is a huge deal. It helps solve one of the biggest, most frustrating problems in AI, which is called catastrophic forgetting. That's when you teach an AI to recognize cats, then you teach it to recognize dogs, and it suddenly goes, wait, what's a cat again? This brain-inspired replay technique lets the AI learn new things while holding on to old knowledge. It enables true continuous learning. So we're not just talking about one clever trick here. This represents a fundamental shift in how we think about building AI. We're moving away from the old model of just throwing massive static data sets at a problem and moving toward creating what these researchers call adaptive intelligence systems, systems that can learn and evolve in real time, just like you and me. So what does this all mean for the future? I mean, if we can really pull this off and build AI based on these brainy principles, the possibilities are, frankly, world-changing. As the researchers behind this work put it, the next frontier is to go beyond traditional AI to develop adaptive intelligence. And that phrase, adaptive intelligence, is everything. This is the big goal, to create machines that don't just compute answers, but can genuinely learn, reason, and navigate the messy complexity of the real world.
So, what does a world with this kind of AI actually look like? Well, imagine robots that can navigate a chaotic disaster zone to find survivors. Or personalized medicine that adapts your treatment based on your body's data hour by hour. Think of a digital assistant that doesn't just wait for commands, but actually understands your context and anticipates what you need. That's the future this research is building.
And that leaves us with one last, really profound question. For decades, we've tried to build intelligence by focusing on pure logic and raw computing power. But what we're learning now is that the key, the real secret, might have been inside our own heads this whole time. So if we finally succeed in building an AI that can learn, adapt, and predict, just like a biological brain, what will it become?